So this is for the practice set. There's a few questions there that are really tricky, but once you know the hints, it actually becomes pretty easy. So first, we got to make sure that your problem has your acid and has your water. So in this situation, they actually put it in there for you. But we have an issue of there's the nitrogen that goes to the original nitrate and to the nitrogen monoxide. So one nitrate can't do both. So my first hint is, well, let's write it twice. So one of the nitrates will stay as a nitrate, but the other nitrate will change into nitrogen monoxide. And again, we're going to balance out because we see that there's two here. Eventually, we'll figure out how to balance out all correctly, but it's best to write them as two separate acids. Again, one acid will stay as a nitrate, another acid will become the nitrogen monoxide. For this particular problem, another trick is to get rid of the the nickel. The nickel is 2 plus here, and it's still a 2 plus. So because it hasn't changed at all, it's a spectator, so we can take it out. Okay, so then I want you to first find the transfer electrons and then balance. The original question is asking you to write them as half reactions, and I don't prefer that method. I feel like it wastes my time, but we're still finding the half reactions by looking for the transfer electrons. So again, we're going to say this nitrogen will change into the nitrogen monoxide. Then we see that the sulfur goes from -2 to 0. Let's write that in, -2 to 0. We know this one is +5 to +2. That is a gain of 3 electrons. And then -2 down to 0, we're going to lose those 2 electrons. Okay, then we need to balance because 3 and 2 do not equal, so I need to times this by 2, times this by 3, and now they're equal for 6. What I just did, I can't ignore, so I'm going to come back up here. So it's going to be 2 nitrates that turn into 2 nitrogen monoxides. That's 3 sulfurs that turn into 3 sulfurs. 3 sulfur ions turn into 3 sulfur atoms. Okay, so now that's pretty much set for the transfer of electrons. In the half reactions, you're also trying to balance out these oxygens, right? If the nitrogen is changing, 2 of those oxygens are disappearing. So that's why we need the water. But then water has hydrogens, so that's why we need the H pluses. So you can sit there and take those reactions out separately. Yeah, this one also has the same issues. So I'll show that in a minute. Okay, so here we're going to write out the HNO3. We know we have 2 of them for now. Is going to make the NO, 2 of them, but I know I need more waters over here. So I have 3 oxygens times 2, it's 6 oxygens. 2 of them already. I'm stuck with 1 here. So I need 6 minus 2, I need 4 of them. So this will become a 4 here. Now 4 times 2, that is my 8. So the hard part is I already got 2, so I need some more H pluses. Well, that's going to come from this here, right? Because if you look at the original equation, the H is here, but that NO3 is going to the NO3. So what we're going to do is we're going to say, okay, I need 4 times 2, I need 8 hydrogens. I already have 2 of them. So I'm going to add 6 more nitrates, or the nitric acids. But then on the other side, I have to add my nitrates. So I need 6 NO3 minuses. And that's okay because it's right here. So when we combined, we'll be able to add that into our nickel nitrate. So That one's probably the hardest one to look at. The sulfur half reaction is S2 minus plus, or goes to sulfur plus the 2 electrons. So that half reaction is straightforward. So then now once we have these balanced, we have to combine and bring it back to the original. So I'll let you work with that. If you want, when you have it done, show me and I will check it for you. And I'm so appreciative of you learning in new ways.